Okay, welcome back. So far, in Pandas, we have learned what to write, and but now it comes the real question: how do we write Pandas code that actually scales? We wrote many codes that related to Pandas that we done in as a data analyst, but we need to deep dive into this and to know how we actually write Pandas code that actually scales. Okay, in this video, I'm going to show why some pandas code feels slow, why some feels clean, and how analysts actually think when working with large datasets. Okay, so this is where pandas start to feel professional. Okay, last time we did all this and we know the basics, we know the intermediate level, and now we are in our advanced. Okay, so let's start with a simple employee dataset. After creating that, I will continue. So we created a simple employee dataset now with about employee department salary experience. We do this with same names and same departments and salary and all. Okay, so this looks simple and very small, but don't underestimate it. Okay, the exact same logic applies when this become 5 million rows. Okay, so we are taking this to understand more, but it can be applied in several rows and columns or into a CSV file also. So we need to understand the logic, don't jump or move into some large data set to know the basic logics. Okay, so Pandas doesn't care if it's 5 rows or 5 million. Your code quality does. Okay, so you understand why we took a simple small data set to apply the code, which is exactly used in 5 million rows or columns. Okay, now we are going to create, first of all, we run this, and now after this run properly, we are going to create a new salary. New salary where you can find a simple empty list. Okay, so we are moving to other. The salary in df salary, place the salary in quotation marks, and then add the column. Now new salary dot append salary with a star asterisk and 1.10. Okay, then we are going to add df with new salary and then loop. Okay, that's equals new salary for df. So what happened here? The for, it's a for loop as we know. It go through the df salary and it will be appended the salary and the 1.10. It will be multiplied and then appended to the new salary. Then, so now let's run and see what is our output look like. So this is how our output look likes. Like now it added a 0. It becomes float. Before that, it was in a integer form. Now it's become float. Okay. So now let's move. And we do a loop here. Okay. You can see we done a for loop. But honestly, most of us started here. But here is the problem. Python loops are slow. So while we are working with large number of columns and rows, the loop work really slow. So if your dataset grows, this becomes much more painful and like take a lot of time. So we don't want our time to be consumed by a loop if we have another solution. Okay. So let me show you how Pandas actually wants to think. Okay. So here, the fast way of doing this through vectorization. Yesterday we talked about vectorization. Today we are again discussing about the vectorization. For that, I'm just making a new salary loop and placing our df salary with that and adding a multiplication with same 1.10. Okay, let's do. After that, I'll talk about. Now we can just copy this and paste here Then we can use equals. Here we said loop, but now we are going to do vectorization. So we are adding vectorized. Then df salary, add the star 1.10, then call df. So as you see here, this single line replaces the entire loop. Now we got the same output, but the real thing is the time. Pandas want you to actually think like this way, using vectorizing ways other than the loop. So this is called vectorization. These single lines replace the entire loop. Okay, so here Pandas handles the heavy lifting internally and in optimized code. So rule number one of advanced Pandas: if you can avoid a loop, avoid it. Okay, or and replace it with vectorization. Okay, so you can do it in a single line of code. That's our first rule in advanced Pandas. Okay, now we are moving to map. For that, I need to create a variable department bonus. So we are actually making a dictionary. So we are opening a curly brace, then HR. Afterwards, we are adding 1.05, comma IT. We are adding 1.10, then finance. We just want to add 1.15. Okay, we added HR, IT, and finance with the values. Okay, now we're gonna do DF bonus multiplier, then equals DF department, and then map department bonus. Just call the TF afterwards. Okay, let's run. What happened? Oh, I'm sorry. I just. So you can see it here. Now this is very realistic. Different departments, different rules. Map is very perfect when you have a dictionary or lookup table. Okay, this is readable, fast, and very common in real projects. Okay, so each table has different rules, and each department has different rules. So what help us to map that? The map itself. Okay, we use the map, and which helped us throughout this way. So it will clean and it will be very much practical. Okay, and now it's much more readable. We added 1.05. How much is our multiplier and all? Okay, so each has a different multiplier, and we get IT has the same, and HR has 1.05. All this. So this is how map work. As you see here, you can read it, and you can read each of it. We made a department bonus dictionary, and afterwards we make a different department with different rules. Each department we give our different values, and it will be placed under this. So then the bonus multiplier was like, yeah, separated with that values. Okay, so now we are moving to apply. That's something really flexible, but we need to be a bit careful while using apply. Okay, for that, I'm using def salary with category, and then add salary. Then if salary is greater than or equal to 70K, then return high, or let's place high in quotes, and else if the salary is greater than or equal to 55K, let's return medium, or else we can just return low. Okay, now we are going to place this under TF equals DF salary category, then which is equal to df salary and dot apply with a salary category df. So here you can see the salary category. Okay, with high, medium, low, and all. We use apply, which is very powerful. It lets you write custom logic. But here is the truth. It's slower than vectorization because, as we know, we are using a loop here, and we are using a if else loop and a function, all this. So because of that, it's slower than vectorization. So while we use apply only when there is no simpler mathematical way, because apply is something to be used carefully, not just used randomly. So now I should say that people are saying apply, use apply carefully, as I said to you. But is apply bad? Did you think so? No, actually apply is not bad. It's something really good, but it can become a problem if we use it everywhere. Okay, let me explain what actually happens behind the scenes. We apply um, when we have a simple small data set. But when we use apply, Pandas runs a Python function for every single row. One row, then the next, then the next. Okay, this is fine for small data sets. But when your data grows to thousands or million rows, this becomes slow. So the issue is not correctness. The issue is performance and scalability. Now compare that with vectorized operations. When we write something like df salary star 1.1, Pandas does the work internally using optimized code, as we do here, like this one. This one. Okay. So when we write like this, Pandas does the work internally. Okay, it optimized the code. No Python loop, much faster execution, and that's why vectorization is always preferred. And here is the real rule. So, if your logic can be returned using math conditions or building pandas functions, don't use apply. If your logic is complex, custom, or business specific, then apply is completely fine. And in real projects, professionals think like, first, can this be vectorized? Second, can I use map or np.var, like np.var? That will be we will learn later. And if those don't work, that's when apply becomes the right choice. So I hope you understand how apply works. And remember, apply is powerful, not dangerous, and we just use it intentionally, not by default. So that's it. And some more things about apply. We done apply inside a function. So apply is not a function, but a method which we used inside a function. Also, while we are using apply, Python codes run row by row, so we use it carefully. Then only vectorization is not possible. Okay, and only that way happens. While we are working with millions of data sets, millions of rows and columns, when we use apply, it will be much longer, take a longer period. But we don't have any choice. If we go through np.var or vectorization, if we don't have all that choices, we use or we take apply intentionally. Okay, so apply is a method, not a function. That's all about apply. I just say about this because while you use this, you should understand how it really works. It works under or inside a function, like it works with the function. Okay, like this, and it goes row by rows and take a lot of time. So when you use it, you should understand it's there. Don't use it as a purpose. Okay, if nothing works, use apply. Okay, that's it. So as we talk about np.var, now we are going to use that. Okay, replacing our apply with np.var. For that, I'm using df experience level, and I'm adding np.var and df experience also, which is we are using a condition greater than 5, greater than or equal to 5 with a comma, then if it's greater than or equal to 5, then senior, and with a comma, junior. Okay, then call our TF, run. Now you can watch here, it is separated by junior and senior without giving like a loop. We used np.word. Okay, so here our np.word gives you speed and clarity. Whenever you are about to write a play, for conditions, stop and ask, can this be done with np.word? So if it's no, then only move to apply. Now, advanced Panda is not about knowing more functions, it's about thinking differently. Can this be vectorized? Or can I avoid row by row logic? Will this survive large dataset? This mindset is what companies actually look for. So while we use anything, you should understand where and what is the purpose and how it works internally. Okay. And so in this part, we didn't just write codes, we learned how to think while writing pandas. In the next video, we will go deeper into memory optimization and data types, which is crucial for real-world datasets. And take your time, experiment with the code, and I will see you in the next part. I hope this will be a good part for you and you understand the concept, mainly the apply. Okay, see you guys.